All right, guys, today we are going to be looking at quadratic transformations yet again. We're going to be looking at, like, if this were my parabola, we're going to be looking at stretches. These are horizontal stretches and horizontal compressions, as well as vertical stretches and vertical compressions. So it's a little bit tricky because of the way it looks, but really we're focusing on whether the graph is getting wider or more narrow. So here we have the idea of a vertical stretch and compression. So if we're going to look at I hot over, so the over part is what we're looking at because these changes are outside of any parentheses. So when we look at this, a stretch is going to be exactly what you think it is. So let's graph. I'm going to go ahead and take the function, just the parent function, and I'm going to graph that here. So when I look at a parent function, that's y equals x squared. Most basic parabola there is. So now I'm actually going to graph y equals 3x squared. Look at what happens to that. Remember, that's the blue one, so that it gets more narrow. So we're talking about a vertical stretch. So we're taking that parabola, and if you imagine a rubber band, taking that rubber band and pulling it one way. And then, of course, let's do the other. So we have y equals, now we have 1/3. I'm going to put it in parentheses just in case it causes us grief. And then we have x squared. So notice this one gets wider. So because it's smaller, you're going to squish it down to make it flatter. So in this case, when we talk about these two, this would be more narrow, and this would be wider. So that's good to know. You may want to write all this down, guys. So we have a vertical stretch and a vertical compression. So just to kind of give you the visual, here's my parabola. If we're talking about a vertical stretch, we're going to be holding it vertically. So vertically is up and down, and we're stretching it to make it more narrow. This is exactly what I was just talking about, more narrow. Then if we're talking about a compression, remember when you compress something, you're pushing it down. So if this is my parabola, I'm pushing it down. I'm compressing it. So this would be when we have a is larger than 1, so we're stretching it. Anything less than 1 or between 0 and 1 would squish it down, okay? Would be compressing it. So now let's look at these horizontal changes. So when we look here, we have y equals x squared as our parent function. And then we're going to have y equals, so we're going to do 1/3 x. So I'm going to put 1/3. Oopsies. Let me try that again. 1/3, and then the x squared inside with it. Now, it's very tricky because it looks exactly like the last one, but because it's inside the parentheses, it changes things a little bit. So because it's inside the parentheses, now we're talking about a stretch that's horizontal, and I'll give you that visual here in just a minute. So now I'm going to graph the next one. So we have y equals, now I'm going to have parentheses again, 3x squared. So again, it got more narrow. So whenever the value is larger, it gets more narrow. The difference here is when we're talking about whether it's horizontal or vertical. So let me show you what that will look like. So horizontally would mean that I'm holding it this way. So to make it more wider horizontally, because it's inside the parentheses, we have to make it a stretch. We're pulling this parabola out. When we're talking about a horizontal compression, we're pushing the parabola in. So horizontal stretch makes it wider. Horizontal compression makes it more narrow. So back to what I was saying, we're talking about this stretch. Horizontal stretch would be wider, and horizontal compression would be narrow. So if you can recognize whether it's getting wider or more narrow, then you can justify or figure out horizontal or vertical, or make an educated guess. All right, now here's a fun one. Here we're talking about reflections. This one is also very tricky because of the fact that it can be over the x or the y-axis. So the y-axis is the one that's tricky. Because let me show you, when we graph the one on the x-axis, we have y equals, I'm starting with my parent function, is x squared, right? Easy peasy. Now I'm going to graph y equals negative x squared. And notice, it just flips it over the x-axis. Now if I go to graph the next one, I have y equals, again, parentheses, negative x squared. Notice, it overlaps with the original parent function. So it's going to look the same. So it'll look the same. But really, what's happening is it's flipping this direction. So it's rotating. Let me show you a visual of that. So here's our parabola. And if we're flipping over the x-axis, if my x-axis is here, it's flipping this way, right? So that means that would be a vertical, and it's exactly what you think. It's just going to go over that x-axis. Perfect, right? Now, if we're talking about a horizontal transformation or reflection, horizontal, this would be your y-axis. It's actually just, sorry, it's hard to do. It's actually just going to reflect this way. So it's going to look exactly the same. All right, so now let's talk about the fact that graphs can be wide or narrow and what all this means. So I'm going to look at this first one. This first one is narrow, so I'm going to indicate that here. So we have a narrow graph. This one is wide, excuse me, and also reflected, right, over that x-axis. This one is narrow and reflected. So we should be looking for something with a different sign. And this one's a little bit wider than the average. So let's look at the choices here. It says A is between -1 and 0. So we're talking about something that's been reflected. So let's say, I'm going to pick a number, so we'd be -1/2. So that means it's potentially going to be this one because it's wider and reflected. Now it says A is between 0 and 1. So again, 1/2. So if that's the case, we would go here because we're talking about it just being wider, but not necessarily reflected. For the next one, it says A is less than -1. So what if I did -3? It's reflected and it's narrow. So then this would be C. And then last but not least, by process of elimination is D. It's greater than 1, so it's narrow. All right, so let's see what we have here. Let's graph a parent function. It's always based on a parent function. So we have y equals x squared. X squared is the most basic quadratic. Keep that in mind. Now I'm going to graph, and instead of f of x, I'm going to use y. Y equals, and x is in the parentheses, so I'm having to do this and square it. So in this case, it's inside our parentheses. So we're talking horizontal. Horizontal is from left to right. It's opposite of what you think. You would think it would look like a reflection, but it's not. So this would be a reflection over the y-axis because it looks the same. And that's it. There's no other transformations going on here. Let's try. So in this case, we have 0.2, which is less than 1. So our graph should be looking wider. So let's see what this looks like. If I go to graph this, remember Desmos is our friend. So now I have 0.2. Whoops, I guess I should put a y equals x squared. So you notice it does get wider. Now, because it's outside of our parentheses, it's vertical. So because it's getting wider, we're holding that parabola vertically, so up and down, and it's getting wider, so that means I'm pushing it down. So in order to get it wider, this would be a vertical compression to make it wider. That's key. So for this one, what I'm actually going to do is I'm going to guess what it would be. So it's inside the parentheses. Because it's inside here, we know that we are looking for a horizontal change. So again, from left to right. It's opposite of what you think. So inside, because it's a smaller number, so 1/2 is less than 1, it's going to get wider, which we know. But because it's horizontal, in order to make it wider, you're holding it from left to right. In order to make it wider, let me do this real quick. So because we're holding it wider, or we want it to get wider, we're holding it horizontally and we want it to get wider. So in this case, it's a horizontal stretch because we're stretching that parabola out in order to make it wider. So then in this case, we would call this a horizontal stretch. Notice I told you at the beginning these were tricky. All right, here's another one. One last one. So we have that negative sign. It's outside the parentheses, so we're talking vertical. So if we have our parent function, it's this guy. Vertically would mean we're flipping over this x-axis, so that means it's going to go this way. So it would be a vertical reflection over the x-axis.